Okay, today we are going to look at section 4.6, which is over our inverse trig functions. So we're going to look at inverse sine, inverse cosine, and inverse tangent. Now we want to make sure that we note that arc sine x is exactly the same thing as inverse sine x. So they are used interchangeably and they mean the same thing, which means they're going to be done the same way. So just because it says arc sine or it says inverse sine, it doesn't matter. It is the exact same thing, just different ways of saying it. So when we look at our inverse trig functions, we need to be aware that they can only happen in certain quadrants. Now, sine itself can be in all four quadrants. However, inverse sine can only be in quadrants 1 and 4. So, inverse sine or arc sine cannot occur in quadrant 2 or in quadrant 3, only in quadrant 1 and 4. So, we want to think about what our domain and our range for those would be. And this is a little bit different. So remember, we're talking about inverse functions. And anytime we talk about an inverse, remember we say that the x and y change, therefore everything related to them switches as well, such as domain and range. So for our sine function, when we graphed those, we said that the y values went anywhere from -1 up to +1. So for our inverse sine, that means our domain is going to go anywhere from -1 to +1. Now, my range for my regular sine function, domain was all real numbers, so -infinity to +infinity. However, that is not the case for inverse sine. It has a restricted range because it can only occur in those two quadrants, quadrant 1 and quadrant 4. Now, when we do this, we don't want to think of this as our normal radian values. So this is still going to be 0. This is still going to be pi over 2. But I am not going to label this one as 3 pi over 2 because in order for that to be 3 pi over 2, you would have had to start at 0 and rotate all the way around here to get to 3 pi over 2. And we're not allowed to do that for inverse sine because remember I said that it cannot exist in quadrant 2 or in quadrant 3, which means we can't even travel through quadrant 2 and 3. So that's basically no man's land. It cannot happen there. Nothing can exist. So how do I get to this location if I can't go around in a positive direction? Well, instead, I'm going to have to go from here in a negative direction. And so if I'm going in a negative direction, that's no longer 3 pi over 2. It's going to be a negative pi over 2. So this is negative pi over 2. So that tells me then that my range is going to go from that negative pi over 2 to positive pi over 2. And then it can be equal to either one. So negative pi over 2 and positive pi over 2 are included. So my range can go anywhere from here to here. All right, so that's inverse sine. Now we need to make sure that we understand those because that's going to affect how and if we can work our upcoming problems. Now we're going to go through a similar thing for cosine. Now, regular cosine we know can be in all four quadrants. However, inverse cosine or arc cosine, same thing, can only occur in quadrants 1 and 2. Cannot happen in quadrants 3 and 4. We're not even allowed to pass through quadrants 3 and 4. But this one's not a big deal because I can go from 0 to pi over 2 to pi in a positive rotation without ever having to go through no man's land. So that one's okay. Therefore, think back to our original cosine function that we graphed the other day. We know that the domain could be anything, negative infinity to positive infinity. The range, however, for our basic cosine function went from -1 to +1. The lowest it went was -1, the highest it went was +1, which tells me that for my inverse cosine or arc cosine, those are going to be reversed. So the domain for inverse cosine can only go from -1 to +1. And my range for this one, well, it can begin at 0, and then it can go in the positive direction. So from here, positive direction around to pi. So my range for this then is going to be from 0, including 0, all the way around to pi, and including pi as well. So that's my domain and range for my inverse cosine. Now, my tangent, or inverse tangent, is going to be very similar to sine. So we're going to have it, just like in sine, it's going to be quadrants 1 and 4. But the difference for inverse tangent is that it cannot actually be on that vertical line. So it can be anywhere in quadrants 1 and 4, but it cannot be on that y-axis. So it can go to -pi/2, so remember, in the negative direction, or in the positive direction to pi/2. So that's my range. My domain, though, so think about this one carefully. My domain for inverse is going to be related to the range of the original tangent. And my range for the inverse is going to be that -pi/2 to +pi/2. Now, be careful, though, because we know it can go from -pi/2 to +pi/2. However, since it cannot actually occur on this line, that's a dotted line, that means that we're not going to have brackets around that like we did for sine. We're going to have parentheses. So it cannot actually be -pi/2, and it cannot actually be +pi/2, but it can be anything in between those. So anything in here, just not actually on the line. Now, domain for inverse tangent. So if we think about the range for the original tangent, so think about when we did our graph, it was, we had, let's see, it went like that, and then we had, oh wait, no, it went the other way. Anyway, so it went up forever and it went down forever. That means that our domain for inverse is going to be -infinity to +infinity. And that's important. So that means that for tangent, since inverse tangent can be anything, then I will always have a solution for inverse tangent. It will never be no solution. However, for inverse sine and inverse cosine, since those domains are limited, that means that I have the potential to have problems that have no solution. So let's look at how that's going to be. All right, so if we look at number 1, we need to find the exact value of each expression if it exists. So the first thing we want to do is, based on which function we're dealing with, determine what two quadrants can that happen in. Can it happen in 1 and 4? Can it happen in 1 and 2? Can it happen in 1 and 4 but not on that y-axis? And we're going to write those two quadrants, and then we're going to figure out where would that actually happen. So sine, we know, occurs in either quadrants 1 or 4. So those are the two possibilities for our quadrants for inverse sine. Now, we are looking for where sine would be 1/2. So when you're doing an inverse, remember, inverse trig functions tell you an angle. So basically, they're giving you the sine value, and they want you to find at what angle that occurs. So since inverse sine can only be in quadrants 1 and 4, then positive sine values would have to be in quadrant 1, because remember, in the unit circle, sine is y, cosine is x. So if sine is going to be positive, well, that would have to be in quadrant 1. So what I'm going to do then is I'm going to go ahead, since I know that it's in quadrant 1, not quadrant 4, because sine would be negative there, I'm going to go ahead and draw myself a reference triangle. Now, it doesn't have to be perfect, because we're going to fill in our numbers and figure out what everything needs to be. Now, sine, remember, is y, which tells me this is going to be the y value. And 1/2 is one of the possible y values from my unit circle, which is great. That makes my life easy. So if the y value is 1/2, so that goes on the vertical component, then think back to your unit circle. The other value that went with 1/2 was √3/2. So if this has to be √3/2, well, then we need to determine what angle is this. Well, 1/2 is shorter than √3/2, which means this is my short leg. Therefore, the angle across from it must be the smaller of my two angles in my 30, 60, 90 triangle. Therefore, this angle is 30 degrees, but I want the exact value, which means I want the radian value of 30 degrees. And 30 degrees is the same thing as pi/6. So your answer is pi/6. So what we're doing is, based on which function it is, arcsine, arccosine, or arctangent, or inverse, we're going to determine what two quadrants that can happen in. Then based on what it is, which of those two quadrants would it have to be, and then figure out your reference angle and then your radian value of that angle. All right, so let's do some more, because right now I know it seems really weird. So let's do some more and it'll hopefully start to make sense. So arcsine is the same thing as inverse sine, and we know that that can only happen in quadrants 1 and 4. Now, sine is the y value, which tells me this is the y. So if the y is negative √2/2, then that has to be in the fourth quadrant, because in the first quadrant, sine would be positive. So if the y value is negative √2/2, then that means across from that would have to be a 45-degree angle. And that means we need to know what the radian value of this is. Now remember, we can't say, oh, well, okay, I'm going to go around here. No, no, no. This is no man's land. I cannot travel through that. So if I can't travel through that, the only way to get to here is to go backwards 45 degrees. And so 45 degrees would be the same thing as pi/4. But remember, we're going backwards to reach that. So it has to be negative pi/4. So that would be that answer. Now take a look at number 3. So sine can only happen, again, inverse sine can only happen in quadrants 1 and 4. Now, 3 is positive. However, think about this. For inverse sine, take a look back over here. My domain for inverse sine must be between -1 and 1. I'm doing inverse sine of 3. This is not within my domain, which means that cannot happen. So this one would simply be no solution. The other ones were okay, because if I take a look at number 1, 1/2, that's in between -1 and 1. Great, we can do that. Number 2, negative √2/2. If you put that in your calculator, you're going to get a decimal, and that decimal is going to be somewhere between -1 and +1. So we were able to do that. However, number 3 is not in between -1 and 1. Therefore, we can't do inverse sine for that, and it's no solution. Okay, so let's look at one more sine function, and then we'll move on to cosine. All right, so arcsine, or inverse sine, same thing, of -1. Well, first thing, is that within our domain? Yes, because our domain can be anywhere from -1 to +1, including -1 and +1. So this is within our domain, just barely, but it is within our domain. Therefore, we want to go ahead and take a look at our two quadrants that arc sine or inverse sine can occur in. So we know that's quadrant 1 and 4. Now, since it is inverse sine of -1, well, remember, this is my y value, so where within those two quadrants would sine be -1? Well, that would actually be down here on the negative y-axis. So it's not actually going to be an angle, it's going to be one of those quadrantals. So we know that this is 0, this is pi over 2, and this is negative pi over 2. So the only place within those two quadrants that we would have a -1 for our y value is down here at negative pi over 2. So that's our answer. All right, let's take a look at some cosine ones then. Now, for cosine, remember, we're going to use two different quadrants. So inverse cosine or arc cosine can only occur in quadrants 1 and 2. Now, also check with these and make sure, is this within my domain? So for arc cosine or inverse cosine, my domain can be anywhere from -1 to +1. So, yes, that is somewhere between -1 and +1. So then, since we know that it's possible, we now look at where within those two quadrants would my cosine be negative square root of 2 over 2. Well, anywhere in the first quadrant, your cosine, your x value, would be positive. So it's not there. Cosine would only be negative over here. So then that has to be happening in the second quadrant. So we draw our triangle. Now, cosine, remember, is x, which means that negative square root of 2 over 2 goes on the x-axis, the horizontal component. And so if the horizontal component is negative square root of 2 over 2, then that means the vertical has to be positive square root of 2 over 2 because y is positive in the second quadrant. And therefore, across from that would have to be 45 degrees. Now, what's the radian value of this angle right here? Well, remember, we're going to start at 0, and we're going to rotate around until we get here. So how far would that be? Well, if the reference angle is 45, that's pi over 4. So think, if this is pi over 4, then we are pi over 4 short of half a rotation, which is pi. So what radian value is that going to be? That's going to be 3 pi over 4. And so that would be our answer. So get it in the correct quadrant and then just figure out what radian value would this have to be based on your reference angle. Alrighty, let's take a look at the next one. So arc cosine, so we know automatically we're using quadrants 1 and 2. And then we want to find arc cosine of 0. Well, is 0 in our domain? Yes, because our domain is -1 to +1, and 0 is firmly within that domain. So then where would cosine be 0? Well, remember, cosine is x, so where within that would x be 0? The only place would be right here. So then, what is the radian value at that location? That is pi over 2. Alrighty, moving on. Number 7, arc cosine, so that tells me quadrants 1 and 2. Then I'm looking for where within those quadrants would my x be -2. And that causes a problem because number 1, it's not in my domain. And it's not in my domain because there is nowhere on the unit circle that your x value would be -2 because a unit circle only goes from -1 to +1. So since -2 is not in my domain, that means that there is no solution for this problem. All right, one more cosine and then we'll move on to tangent. So we're doing inverse cosine. Therefore, we know that we're using quadrants 1 and 2 only. Then, where within those two quadrants would the x value be -√3/2? Well, cosine is negative in quadrant 2, not in quadrant 1. Cosine is positive in quadrant 1. Therefore, it has to be quadrant 2. So I draw my reference triangle, and cosine is the x value, which means that -√3/2 has to be the x value, so on the x-axis, which means this must be a 30, 60, 90 triangle. So if one side is √3/2, the other side has to be 1/2. And our reference angle is across from the smaller side, which means that must be 30 degrees. Therefore, what is the radian measure of this angle? Well, if that's 30 degrees is the same thing as pi/6. So this is pi/6 away from pi, which means, so if this is pi, which is same thing as 6 pi/6, and then this is pi/6 away from it, that means that would have to be 5 pi/6. So my answer is 5 pi/6. So you're looking at what angle would this be 1/2 and this be -√3/2. All right, so that's our cosine. Let's take a look at tangent now. So tangent will never be no solution because our domain for tangent is anything. So there is nothing off limits for inverse or arc tangent. So sine, inverse sine, and inverse cosine can possibly have no solution, but tangent will always have a solution. Now, we are still restricted as to what quadrants we can use. So inverse tangent can use the first and fourth quadrant, but it cannot actually occur on that line. So it can occur on the positive x-axis, but it cannot occur on the y-axis anywhere. So now I want to figure out, first of all, quadrant 1 or 4, which one would tangent be positive? Well, tangent is positive in the first quadrant and the third quadrant, but not the fourth. Therefore, it must be occurring in the first quadrant, and I'm going to go ahead and draw my reference triangle and figure out where in the world is this located on my unit circle. So this itself is not something that we saw in the unit circle. However, we can modify this a little bit to figure it out. So remember, tangent is y/x. So we need to think of this as a fraction. So I'm going to say that this is the √3/1. And then I think, in my unit circle, I had some things that would simplify to give me that. So I could take each of those and put them over 2. And then what do you know? Those are 2 values from my unit circle. So that means that the y has to be the √3/2. So y is √3/2. And then the x has to be the 1/2. So now I just need to figure out at what angle does that occur. So if this is across from √3/2, that means this has to be a 60-degree angle. Therefore, the radian would be pi/3. So that's my answer. So inverse tangent is pi/3. So those take a little bit more thought because tangent isn't just simply x or just simply y. it's y over x and then simplified. So we have to basically unsimplify the fraction and then figure out where that would be on our unit circle. All right, so let's take a look at a few more of those, because like I said, those are going to take a little bit more thought. So we have arctangent again, so we know that that has to occur in quadrants 1 or 4. Cannot be on the y-axis, but it could be on the positive x-axis. Now, I want to know where tangent would be 0. Well, think about it. Remember, tangent is y over x, so then I'm going to say that that's really 0 over 1. So if it's y over x, that means the y has to be 0, the x has to be 1. So that means that I have a point of x is 1, y is 0, and hey, that would be right here. So that's okay. It can exist there. It can't exist here, it can't exist here, but it can exist on the positive x-axis. So we're good. So what I really need to know then is, what radian value is this? And that's 0. So arctangent of 0 equals 0. Technically 0 pi, but it's 0. All right, the next one, number 11. I want inverse tangent of -1. So remember, we need to make this a fraction. So I'm going to say that that's -1 over 1, which means this is my y, this is my x. So then, that's a little bit weird because there is nowhere on my unit circle that I have both the x and the y value as 1. My radius is 1, not my x and y values. However, think about it. If I'm going to have something simplified to give me 1, that tells me that the x and the y value have to be the same. However, since it came out to be a negative, since it came out to be a negative, that means one of them has to be positive, one of them has to be negative. So let's back up and let's think, which quadrant would my tangent be negative? So remember, in quadrant 1, everything's positive. Sine is positive, cosine is positive, tangent is positive. So it can't be quadrant 1. That means it has to be quadrant 4. So then, in quadrant 4, my x would be positive, my y would be negative. So that would give me a negative tangent. Now, since I need for it to simplify to give me a version of 1, that tells me that the x and y value have to be the same. So I can go ahead and write this as the y value would be -1, the x value would be +1. So if they're the same thing but opposite signs, there's only one angle that does that, and that's 45 degrees. So that means that our sides are really actually square root of 2 over 2 and negative square root of 2 over 2. That gives me my 45-degree angle, but then I need the radian measure of this. So remember, we can't go around to here. We have to go backwards. So if I'm going backwards 45 degrees, then that means that that is -pi/4. All right, let's look at one more of these, and then we'll move on to something a little bit different. So once we get the hang of these, they are actually pretty quick and easy to get through. So hopefully this assignment won't take you quite as long as some of the graphing ones. All right, so for number 12, we have arctangent, which we know cannot occur on the y-axis, but it can occur anywhere in quadrant 1 or 4, or on the positive x-axis. So we know that we are looking for where tangent is negative. So which one of those quadrants would tangent be negative? Quadrant 4. So we're going to go ahead and draw our triangle in quadrant 4. And now we are looking for where in the world would we have negative square root of 3 over 3. Well, nowhere in the unit circle do we have negative square root of 3 over 3. However, think about this. We have a 3 here and a 3 here, which tells me that this is most likely a rationalized answer. So I want to unrationalize it. So I need to change it from its rationalized form to what it would have been before we rationalized it. So if this came out to be 3 on the bottom, then that means that it had to have originally been the square root of 3. Well, then that means that on top, if this is square root of 3, then that means originally it would have had to have had that 1. So this would be -1 over square root of 3. That's the same thing. That's the unrationalized version of this. And think about it. If you try to rationalize this, we do times the square root of 3 times the square root of 3, which gives us -1 square root of 3 over 3. So sure enough, we get that. So we need to unrationalize. So we're going to do, whoopsies, there we go. So this is actually what we're looking for. Now again, I don't have anywhere on the unit circle that gives me a -1 and a square root of 3. But just like on that other one, we can easily make this into values from the unit circle by saying, oh hey, what if I put that over 2 and that over 2? Now those are values from my unit circle. So which one goes where? Well, remember, tangent is y over x. So that means the y is -1/2, and the x is positive square root of 3 over 2. Now think about, what does that mean that this angle is? Well, I know that across from 1/2 would have to be 30 degrees. And so if I'm going backwards 30 degrees, that's going to take me to a -π/6. So that means that is going to be my answer, -π/6. So tangent, I think, can be the most challenging of the 3. Sine and cosine, not too bad. Just make sure that whatever you're doing is within your domain. Figure out which quadrant it would be in, and then figure out your triangle, what angle that would be. Tangent, sometimes we have to play with, though, because we have to create the values from our unit circle to figure out where in the world we're talking about. Okay, so you're going to play with those and practice them. We want to move on to the next thing. So we've got some inverse trig properties that we want to use. So we're going to think about this algebraically. So think algebraically, we do whatever's inside grouping symbols, which means first thing we want to do is figure out if this thing inside is even possible. So we've got an inverse sine, and we know that inverse sine, the domain must be between -1 and 1, and our -1/4 is. So that's good. That's great. Then, because that is possible, we know this is possible. Great. Then I have a regular sine and an inverse sine. Well, those are inverse functions, which means they cancel each other out. Therefore, as long as this can happen, then the sine and the inverse sine cancel each other out, and my answer is -1/4. So as long as this can happen, then the regular and the inverse cancel each other out, and whatever's left is your answer. Now, what about number 2? So first of all, we need to decide, can this happen? So tangent of π/2. Now, this is not inverse tangent. This is regular tangent. So if I'm looking at regular tangent of π/2, we know that the point there would be 0, 1, and tangent is y/x. So the y value at that point is 1, the x value is 0, which means that is undefined. So if this is undefined, then I can't just say, oh, hey, well, then those cancel out. No, because it's canceling out for something that's undefined. So if this inner piece is undefined, then that means I can't do the problem at all, and this is automatically no solution. So when we're talking about just plain old inverse tangent or arctangent, you will never have no solution. However, this is not just plain old arctangent or inverse tangent. You have to first make sure that this is even possible. Now, if that was possible, then those would cancel and whatever was left would be your answer. However, because this is not possible, it's undefined, that means I can't do the rest and it's no solution. So hopefully that kind of makes sense. All right, let's take a look at number 3. So first thing we want to do is figure out, can this even happen? Well, sure. I can get sine at any value on my unit circle because there is always a y value, and on the unit circle, sine is y. So anywhere on the unit circle has a y value. Could be 0, could be 1, could be 1/2, could be root 3 over 2, negative versions of any of that, but sine can always have a y value, which means this is definitely possible. Now, because it's possible, we want to say, okay, arcsine and sine cancel, and our answer is 7 pi over 4. However, remember that according to, over here, my range can only be between negative pi over 2 and positive pi over 2. So my answer has to be somewhere in between that. 7 pi over 4 is not in there. So we have to think about what the version of that would be within my parameters. So if I do my arcsine, I know that can be in quadrant 1 and 4. So we want to think about where would sine or 7 pi over 4 be? Would that be in the first quadrant or the fourth quadrant? So if I'm just looking at this, 7 pi over 4 would go around to here. Now remember, I'm not dealing with the arcsine yet. I'm just doing sine of 7 pi over 4. So it would be in the fourth quadrant. So I'm going to go ahead and draw my triangle. So that's my 7 pi over 4. And actually, I'm not even sure I need a triangle here. So that's where 7 pi over 4 would be. However, because I am doing arcsine, I can't say I'm going around here. I can't pass through no man's land. I have to say I'm starting at my initial side and I'm going backwards. So how far am I going backwards to get to this? Well, if that would be normally 7 pi over 4, that means we're having to go backwards pi over 4. So my answer would be negative pi over 4. So it's not always just a matter of saying, oh, hey, those cancel, and that's my answer. I need to realize that 7 pi over 4 is not within that range that we can have, so we need to convert this to a negative angle that is within that range. Alrighty, next we have arcsine of sine of 2 pi over 3. So first of all, where in the world would this be? So we know that since we're going to do eventually arcsine, I'm only going to be looking at these two quadrants. So 2 pi over 3 would normally be over here. But that's a problem because that is not within our range. So if this is 2 pi over 3, and we've got to really think about this one. Remember that sine is y. So I'm going to go ahead and draw my other part of the axis just so I can kind of see. So sine is y. So if I go ahead and complete that triangle, then I am looking for somewhere in these two quadrants where I'm allowed to have arcsine that would have the same y value as this triangle right here. So would that be in quadrant 1 or would that be in quadrant 4? Well, for 2 pi over 3, that's going to be a positive y value. Sine is y, and it's positive in quadrant 3. So in quadrant 1 or 4, the only one of those that would have a positive sine value would be quadrant 1. So we're going to have an equivalent triangle in quadrant 1. So we know whatever this is going to be the same thing. So then we want to figure out what this angle right here is. Well, if we have this is 2 pi over 3, well, remember, that is pi over 3 away from my horizontal, which means this has to be pi over 3 away from my horizontal. So this has to be pi over 3. And that's my answer. So that one takes a little bit more thought. So you're looking at, arc sine can only happen here. And so you're looking at which quadrant, 1 or 4, would have the same sine value as this right here. And so it would have to be the first quadrant. Therefore, look at the same distance from the horizontal. Okay, that's a big old mess. All right, let's go ahead and try a couple more of those. So for number 5, first thing we want to do is figure out where in the world is this. So I'm going to go ahead and do my full axes. Now, where would 7 pi over 6 be? Well, that's just a little bit more than pi, so that tells me that it's going to be over here somewhere. Now, that's great, except remember that inverse cosine can only happen up here. So, cosine is x, therefore I need to know, would the same angle in quadrant 1 or quadrant 2 have the same x value? Well, for our 7 pi over 6, the x value would be negative, which means in my matching angle within my inverse cosine, so somewhere in here, my x has to also be negative. So that means it would have to be in quadrant 2. So then, if this is 7 pi over 6, then that means that is pi over 6 away from the horizontal, which means this has to be pi over 6 away from the horizontal, which means that it would be 5 pi over 6. And remember, for cosine, we can go straight from 0 around to here. So our answer is just going to be 5 pi over 6. All right, then for number 6, okay, we have two totally different functions. So we're going to start on the inside, and then we're going to figure out what cosine would be. So when you have two different functions like this, you are basically taking what you have on the inside to create a triangle that you may or may not have to complete in order to do cosine. So we're going to start first of all with our inverse tangent. We know inverse tangent can only occur in the first and fourth quadrant, and it cannot actually lie on the y-axis. So we know that for that inverse tangent, it is supposed to come out negative. Well, tangent is only negative in the fourth quadrant out of these two options. So we know that we are looking at something in quadrant 4. Now remember that tangent is y over x. So that means this has to be my y, this has to be my x. So I'm going to label my triangle. So the y has to be the 3, the x has to be the 4, and then that negative is going to go in the appropriate place based on our quadrant. So in the fourth quadrant, it would be the y that's negative, and the x would be positive. Now, once we have that labeled, we are now done with that. We don't need it anymore. We are now looking at doing cosine of this triangle. Well, if this is my theta, and cosine, this is obviously not a unit circle, which means I cannot just say, oh, hey, radius is 1. No, no, no. Therefore, I need to find out what that radius would be. That means Pythagorean theorem. Or if we're really lucky, this might be a triple. And this one happens to be a triple, which is very nice. We like when that happens. But remember that when it is not a unit circle, we can't say that cosine is just x. we have to say that cosine is x over r. So we need to find our r. So if you don't know your triples, that's fine. You can do Pythagorean theorem. You need to remember that the hypotenuse is always your c, which means these are your a and your b. Doesn't matter which one is which. So if you need to do the Pythagorean theorem, fine, we can do that. So we're going to have 4 squared plus negative 3 squared equals c squared. Then we have 16 plus 9 equals c squared. Added together, that is 25 equals c squared. And then if I take the square root, that means c must be 5. So if this is 5, so r equals 5, then I can do cosine. Cosine is x over r, so that means my answer is the x, which is 4, over the r, which is 5. And so then that would be our answer. So you're going to use this to figure out which quadrant your triangle needs to be in, label your sides, and then from that, you're going to complete your triangle and then find whichever function it is they want you to find. All right, let's try one more of those, and then we will be done for the day. So we have 2 separate functions, which means we're going to use this to set up my triangle. So I know that arctangent can only occur in quadrants 1 and 4. And we are looking for where the tangent would be a positive 5 over 12. Well, out of those 2 quadrants, 1 and 4, tangent is only positive in quadrant 1. So we go ahead and draw our triangle. Now remember though that tangent is y over x, so that means that this must be the y, this must be the x. So I'm going to fill in 5 for my y, 12 for my x, and then from that I want to find sine. Well, sine is y over r, and I don't know r, which means I need to find it. So that means this is going to be my a, this is going to be my b, or vice versa, and this must be my c. It's my hypotenuse. So I'm going to do 5 squared plus 12 squared equals c squared. Well, 5 squared is 25. 12 squared is 144. Then I can add those together, which gives me 169. And that is actually a perfect square. So the square root of 169 is 13. Now, those don't always come out to be nice, neat numbers. It's possible you could get a radical, and that's okay. We know how to set up fractions with radicals and rationalize them if we need to. So, but in this case, it comes out nice and neat. So r is simply 13. So to do sine for that triangle, we're going to do y, which is 5, over r, which is 13. And so then that would be our answer. All right, so we've done a lot of things, some of them very simple, some of them a little bit more complicated, but once we get the hang of it, it's all not too bad. So I want you guys to work on your homework. Don't waste your time. Actually work on your homework. And then take it step by step. Don't try to do too much at once. And then if you have any questions, I will be happy to help. All right, I will see you guys next time. Remember that you have a test in a couple of days. So when you finish, you're going to want to work on your review. And then